Hey Jordan, what's that you're reading? Looks intense.
Hey Alex, it's this new paper. Small language models are the future of agentic AI. It's a position paper from some folks at NVIDIA and Georgia Tech, and honestly, it's kind of blowing my mind.
Oh yeah? Agentic AI. That's like AI agents that can do stuff for you, right? Like book flights or manage your code?
Exactly. And the paper's whole argument is that we're building them all wrong. They're making a pretty bold claim that small language models, SLMs, are the future for these agents, not the massive LLMs everyone is obsessed with.
Wait, really? But aren't the huge models like GPT-4 the ones that are actually smart enough to do anything useful? I thought bigger was always better with this stuff.
That's what I thought too. But they lay out a really compelling case.
Okay, I'm intrigued. What's the issue with how we build AI agents now? What are we doing wrong?
So right now, the standard approach is to just plug a giant, general-purpose LLM into an agent for literally everything. It's the agent's brain for every single decision, no matter how small.
And that's bad?
It's super inefficient. The authors argue it's a massive misallocation of resources. Think about it. Most of the tasks an agent does are actually really simple and repetitive. Stuff like formatting an API call, extracting a name from an email, or following a script. They're not writing a sonnet or debating philosophy every time they do something.
Huh. Okay, that makes sense. You don't need a supercomputer to add 2 plus 2.
Exactly. They're saying we're using this incredibly powerful, expensive, and slow tool for tons of tasks that a much simpler tool could handle perfectly. It's like using a sledgehammer to crack a nut. It makes the whole system clunky, expensive to run, and way slower than it needs to be.
So what's their big idea? Just use smaller models instead?
Pretty much, but it's more nuanced than that. They're advocating for what they call an SLM-first architecture. It's a completely different way of thinking about building the agent.
An SLM-first architecture? What does that look like?
Instead of one giant brain, imagine the agent is built like a team of specialists. You'd have a bunch of different small language models, and each one is an expert at one specific thing. One SLM might be an expert at understanding user intent. Another is fine-tuned to perfection just for generating code to call your company's internal API. Another's only job is to summarize meeting notes in a very specific format. It's a modular, Lego-like approach.
Okay, so you have a whole squad of little expert models. But what happens when the agent needs to do something actually complicated? Something that needs real reasoning?
That's the brilliant part. For those rare, complex tasks, the agent can then make a single, targeted call to a big LLM. The LLM becomes the specialist you call in for the hard problems, not the one you bother with mundane paperwork. This way, you get the best of both worlds, the efficiency and speed of SLMs for 90% of the work, and the raw power of an LLM for the other 10%. They call it a heterogeneous system.
That's actually a really smart design. It seems so obvious now that you say it.
I know, right? And to make it even more practical, they actually outline a whole 6-step algorithm for how a company could convert its existing LLM-based agent into this new SLM-first system. They talk about logging all the agent's actions, clustering them into distinct tasks, and then fine-tuning specific SLMs for each task cluster. It's a real roadmap.
Okay, it sounds good in theory. But does it actually work? Are these small models even powerful enough to replace an LLM for those tasks?
That was my big question too. And the paper hits that head on. They say that as a position paper, it's more about the argument, but they back it up with a ton of recent examples. Modern SLMs are apparently way more capable than we think.
Like what?
They mention a bunch. Microsoft's PHI-3 model, which is a 7 billion parameter model, apparently performs on par with models 10 times its size for things like common sense reasoning and code generation. Then there's NVIDIA's own Nemotron-H family, which uses a hybrid architecture to be super efficient at instruction following. They're basically saying that the performance gap is closing fast, especially for the specific, structured tasks that agents do.
No way. So the little guys are catching up. What about the cost? Is it really that much cheaper?
Oh, the numbers they quote are wild. They say serving a 7 billion parameter SLM is somewhere between 10 to 30 times cheaper than a big 175 billion parameter LLM. That's across the board. Latency, energy consumption, everything. It's a massive difference in operational cost.
30 times cheaper? That's insane. Any company would jump at that.
And it's not just cost, they're more flexible. You can fine-tune an SLM overnight, not over weeks. You can even run them directly on a laptop or a phone, which is huge for privacy and speed. It opens up a more democratic way of developing these things, instead of everything being controlled by a few companies with giant data centers.
Did they have any concrete examples of this in action?
Yeah, they did. This was one of the coolest parts. They included a few case studies where they analyzed popular open-source agents to see how many of the LLM calls could be swapped out. For an agent called MetaGPT, which helps with software development, they estimated that about 60% of its LLM queries could be handled by a specialized SLM. And for another one called Cradle, which controls a computer's GUI, they estimated 70%.
Wow. So over half the work in existing agents doesn't even need a big model. That really drives the point home. Okay, I'm sold. This seems like a no-brainer. So what's the final word from the paper? What's the big takeaway?
Their conclusion is pretty forceful. They say that this shift from LLM-centric to SLM-first architectures isn't just a good idea, it's basically an inevitable future for agentic AI. The economic and operational pressures are just too strong to ignore. It's the more sustainable, practical, and cost-effective way forward.
So why isn't everyone already doing this? What's stopping them?
They touch on that too. They call it industry inertia. There's been so much money and hype poured into building this massive, centralized LLM infrastructure that the whole ecosystem is built around it right now. And a lot of the benchmarks we use to judge models are for general knowledge, not for the specific, agent-like tasks where SLMs shine. But they believe that as the economic benefits become undeniable, the trend will shift.
That makes total sense. It's a big ship to turn. But it sounds like the destination is clear.
Totally. The paper is basically a call to action, saying, hey everyone, let's start using the right tool for the job and build smarter, more efficient AI agents. It's a pretty powerful message.
Wow. Thanks for breaking that down for me. I feel like I just got a glimpse of the future.
No problem. It's fascinating stuff. Anyway, I should get back to this.
For sure. Catch you later.
Later.